Bobcats? Welcome to our next unit. We are going to start with comparing some proportional applications with some non-proportional applications. So we're moving from solving equations to working with some linear equations and looking at patterns and costs and maybe one-time costs, okay? So you are at Galveston for a week-long gathering. Members of your family want to rent a jet ski. It will cost $40 for a deposit plus $25 for an hour or per hour. How long can you rent the jet ski if your family has budgeted $350 for the rental fee? All right, so I'm already kind of thinking, before I move any further, 0 hours on this jet ski will cost $0 or no? You might be thinking, yeah, Miss Kelly, but if we actually go along with this situation, how much does it cost initially before we have any fun on this jet ski? It costs $40 before you even begin the hour of fun, okay? So for 1 hour, right, wouldn't that be 25 times 1 plus that 40? Right? So hopefully you're doing 25 times 1 plus 40 and you're getting 65. Well, now what about 2 hours, right? Well, wouldn't that be $25 times 2 plus 40? So that would be 50 plus 40, that would be 90. And you can be doing those in your calculator if you need to. 25 times 3 hours plus 40. So that would be 75. 75 plus 40 is 110. Anybody gonna correct me? Miss Kelly, you're making a mistake. It's 115. Those of you doing it in your calculator caught that. All right, now we'll do 4 hours of jet ski fun. That would be $100 plus that $40 deposit, right? So that would be $140. Well, we're gonna carry it on. I'm gonna pause and you're gonna fill in those bottom two. Okay, so 165 and 190. What I'm wanting you to notice is that every hour, right, we increased by $25, and that makes sense because every hour was 25. And I want you to know that we were increasing by 1 hour. So for every 1 hour, it's $25 on this jet ski with an initial deposit of $40. Okay, so there's that. Now we haven't really answered the question yet, but down here we are going to graph this. Right? Let me get rid of that glare a little bit for you. Okay, so when graphing, right, they're asking us to put in some numbers down here. So let's see here. This is going to be my x, my number of hours. Do you see how we're going up by ones? So I'm going to say 0, 0, and I'm going to skip a line. So I skipped a line 1, skipped a line 2, skipped a line 3, skipped a line 4, skipped a line 5. Do you get my pattern that I'm doing? Okay, and then here, I think a good thing to go up by would either be 30s or 15, right? I need to go up to at least 190 and preferably 350, right? So I can do, so we'll say 15, 30, 45, 60. So what I'm really going to do, I'm going to do this for myself to kind of help. I'm going to go up by 30s, but I've skipped a line, so I'm really going up by 15. Yeah, and then plus 30, right, and then 30, 60, 90, 120, 150, 180, 210, and we're just going to keep on going. And that was perfect, because I wanted to at least go to 350. Okay, so what I'm going to do is I'm actually going to plot ordered points, but I want you to know where the points are. So we'll start with 0, 40. So 0, 40 is an ordered pair, right? 165, 290. Do you get what I'm doing? Okay, so I'm going to plot those here on my graph. So 0, this in between would be 45, so 40 would be right under. For 1, it was 65, so a little bit over. For 2, it was 90. Now, let's see here. I feel like 7, right? 7 times 25 plus 40. That's 215. I was hoping it would land perfectly. So 8 would be 240. Okay, so I kind of carried this a little bit further so I could know. So 8, I skipped 8, y'all. Nobody's gonna tell me. 9, 10. Okay, so 8 be 240. So see how I kind of picked ones, right? And that's going to help me stay in line. So 3, and that's 115, so that'll be right below. 4 would be 140, so right below. 5 is 165. That would be perfectly on that one. And then 6 is 190, and then 7 is 215. All right, and then from here I can connect, and this linear, right, represents my jet ski example. So this would be my graph. This is my table, and this is my verbal, right? You've got all 3 pieces there. So how many hours can we budget at 350? Now what you'll kind of notice is I tried to go up, but do you see my graph really isn't helping me, but I can like follow it out, right? And say, okay, well, 350, right? Keep it going. So I know it's going to be greater than 10 hours, right? So what I could do, right, is keep my table going. So, and I'm making sure you know X and Y. I'm just keeping it going. So we said 7, 215, 8 was 240. So what I'm going to do is I'm just going to add 25 each time, right? Isn't that my pattern? I'm a horrible player. All right, so 240 plus 25 plus 25. Okay, so 265, 10 is 290, 11, make sure I'm doing that right, 240, 265, 290, 315, and I feel like we're going to bust here. What do y'all think? So plus 25. Ooh, we didn't bust. But now we'll definitely bust. Okay. So, my family has, ooh, bad glare, sorry. My family has $350. So how many hours? 12 hours on the jet ski. They're not going to let us do 13 because we go over budget. Is this a proportional or non-proportional relationship? Well, a big factor here is when my line, my linear equation goes through 0, 0, meaning at 0 hours, it costs $0. Well, that wasn't our experience. Our experience was that at $0, it costs $40. So we would say this is non-proportional because of the $40 deposit. It was not 0, 0, it was 0, 40. All right, another example, okay? And this one's going to be a little bit different. Hopefully you catch on. We're at Galveston, same scenario. Members of my family want to rent a jet ski. It will cost $45 per hour. How long can we rent the jet ski? For $350. So it's almost like company A, company B, right? Which one's better for my family? So here, I didn't see anything about a deposit, right? So this situation is 0, 0. And what I'm going to do is I'm just going to say, well, 45 times 1, 45 times 2. Where are you getting that 45? Well, it's 45 per hour. So I'm just going to finish this out. I want you to use your calculator. I'm going to pause so you get those matching Y values, the total cost. Okay, so what I've done is I've finished it out, right? So for 1 hour, 2 hour, all the way. And then what I went ahead and did is I said, well, I need to go to 350, right? I didn't mean to mark that out. I was meant to be like down here. So 45 times 7 hours is 315. Well, I busted 8 hours, okay? Well, then what I did is I said, well, remember, these are just ordered pairs, right? 0, 0, 145, 290, 3, 135, 0, 0. 145, 290, 3, 145. Now maybe you're going, well, Miss Kelly, how do you know? Well, remember I was really going up by 15ths. So 15, 30, 45, 60, 75, 90, right? And then I believe that's 115. No, that's not right. Did I get off a little bit here? No, I did right. 115. And then, maybe I didn't do right. Let's see here. So, 90 plus 15. 105, Miss Kelly. Make sure y'all are correcting me. Plus 15. 120. Okay, so 105, 120. And then plus 15 would be 135. Okay, so the increments in between, that might be why you're getting off with the graphing. Okay, so I can see though, look, well, that's 8 hours, so I must be able to ride this for 7 hours, okay, to not go over my budget. So is this proportional or non-proportional? It goes through 0, 0 because at 0 hours, it's $0. So yes, there is no deposit or fee, all right, for 0 hours. We'll keep this moving right along. All right, so we're going to tell if it's proportional or non, and then we're going to fill in the table in the graph. So Rodney earns $8 per hour working at Bobcat Burger. So let's start with 0. Okay, so 0 times 8 is 8. 1 times 8 is 8. 2 times 8. What? Y'all, correct me. 0 times 8 is 0. 1 times 8 is 8. 2 times 8 is 16. So essentially what I'm doing here is I'm saying 2 times X, the number of hours, equals Y, the amount earned. So I'm just going to turn that around, and there's my equation. Yes, this is proportional because it goes through 0, 0, right? So over here at 1 hour, we'll do 0, 0 first. 1 is 8, and 2 is 16. And we'll make that straight. All right. So here, there's no verbal, but I can see, look, 6 times, right, like lawns mowed. Ooh, amount earned. Okay, so 6 times 1 lawn plus 4 is 10. 6 times 2 lawns plus 4 is 16. So I'm going $6 per lawn, and then say plus a $4 gas fee, right? Because there's an initial $4, meaning 0 lawns times $6 plus 4 is going to be 4, right? So we need an initial fee. So at 0, I already know it's 4, so this is non-proportional. proportional, right? So is it proportional? No, right? It is 0, 4. Okay, so the equation, going back to the equation, this would be 6 times x equals y. So 6 times x equals y, and then my equation, right? So we can just keep it going. And what I kind of want you to notice, do you see how we're adding 4 each time? Miss Kelly, we're not adding 4, we're adding 6. Holy moly, I keep making mistakes. All right, so 4 plus 6 is 10, 10 plus 6 is 16, 16 plus 6 is 22, 6 per line, right? Okay, so at 1, it's 16, very steep line there, okay? Last 2 examples. Is it proportional? So what we're going to do is we're going to say y divided by x for both of these. This is a trick, not really a trick, it's the formula for it, but this is the fastest way. 2.5 divided by 1 is 2.5. 5 divided by 2 is 2.5. 7.5 divided by 3 is 2.5. 10 divided by 4 is 2.5. So yes, 2.5. We're going to call that the k right now. We're going to come back to that later. But we get a constant of 2.5. Okay? Over here, y divided by x. 15 divided by 3, 5. 25 divided by 5, 5. 35 divided by 7, 5. 45 divided by 9, 5. See how we get that 5? You didn't see it, but they're 5 every time. You could also say, hey, Miss Kelly, what about it like this? Does that work? Yes, it does. Yes, these are proportional. We get a constant of 5. Y'all stay safe and be kind, Bobcats.